Okay, in this video I need to make a correction. Actually, I goofed up in the previous video. When I was talking about here in the UTF-8 folder, we were looking at Win 10 Arial, and I said that this is decimal value 33, which it is. Okay. I also said this was decimal value 127, which is the highest value you can store in a positive number in an 8-bit signed char or signed byte, and that's not true. This is actually 7E, which is one less than that. This is decimal value 126. Okay. Decimal value 127 would be 7F. Okay. And it's actually not a visible character. It's the delete key. Not sure why that is, but that's what it is. So anyway, the full range of visible characters in the standard ASCII character set, which is everything that can be stored within the first 7 bits of a byte. That is all the positive values. Starts with a bang and ends with a tilde, and it goes from value 33 in decimal to value 126 in decimal, or value 21 in hex to 7E in hex. Okay. All right. Something else I want to show you that's kind of interesting. All right. What we made in the previous video was the standard ASCII character set. Right? In other words, none of the extended Unicode characters that exist outside of it. We just concentrated on ASCII. So I want to show you something here. Oops. All right, what's going on with this? Ran the wrong thing. Gotta run the batch file. Okay. In this batch file, we just have the instruction to run it at 1600 pixels wide by 1000 pixels high in the window that it opens. Alright, so that's what we did. That's how we get to here. This is 1600 pixels wide and 1000 pixels high. This is your standard HD resolution of 1920 by 1080. Alright, so it fits nicely in there. Alright, so we're going to go ahead and open up the DXF file again that made this font. So choose 5, and we're going to say 110 Arial, and it's doing its thing. Now here, we're going to answer no, which means I can hit any key other than the Y key, and we're going to say no, don't rename the frame. So we'll say no, and see now, the frame names are irrelevant. They don't even show up because they're just nonsense. They're just indexed through the numbers of frames that there are. So there's no correlation now between this character and any value stored in the name of this frame. Okay, so now if I save this as it is without messing with it at all, say O to output, 1 for tilde, 3 to go into the fonts directory, and 3 to save all of the frames. We'll just call this Arial 1. Okay, Arial _1. So now that exists. Okay, so now let's verify that we actually got what we think we got. So I'm going to go I to import a file, 1 for tilde, 1 to stay in the fonts directory, and we just made Arial _1. We'll bring this in, and there it is. All right, and as you can see, it starts with a bang, ends with a tilde, and there's a total of, this is the 93rd frame starting at an index of 0, so there are in fact 94 frames. Now this, remember, we didn't do any correction with moving it down to the baseline or any of that stuff. This is just how it was when we imported that DXF file and pulled out the individual characters. All right, so in this form, it is usable, and this, it doesn't have the frame names as Unicode values. It just has, something that is associated with the actual frame index itself. Say this is frame index 6, and it's named 6. Okay, so there's no correlation between this character and a name in Unicode because this is not a hexadecimal thing. All right, so now in this form, this is how LaserBoy used to interpret vector font files for I don't know, the past 12 or 13 years, something like that. It is standard ASCII. It's nothing outside of standard ASCII. It begins with a bang, ends with a tilde, has 94 characters in it. And apparently this is also compatible with another application called LaserShowGen, which also uses LaserBoy font frames so that you can render text in LaserShowGen. Okay, so just to demonstrate that this is backwards compatible with what existed before, like I said, we've already saved this. It does not have Unicode character names, but it is just standard ASCII and nothing else. So we're going to go into our text file. You remember, this is what we used to demonstrate that we got the font. Okay, here's how we made the UTF-8 file. And then we copied the whole string of characters, pasted it into Inkscape, saved it as DXF, opened it back into LaserBoy as a frame set, and we didn't choose to name the frames according to their Unicode character values. We just left that alone. So now down here, this is where it displays things on the screen, so it actually renders something. So let's go ahead and make this Arial_1. So we're going to use that font that we just made, and just to designate that it's different, we'll make it yellow. Alright, so save this and open this in 4 for text file. Win10 Arial is the name of the text file. And replace the current frame set. And there it is, and it's in yellow. And it still works because the frame set that we made is just standard ASCII, and it is in the correct order. So when LaserBoy opens up that font file, it looks at the file name or the frame names, and it says these aren't hexadecimal values. So it just says, all right, let's default to the previous way we deal with this, which is just standard ASCII from the bang to the tilde. So it knows how to render it. And this, again, this is how LaserShowGen would interpret it as well. All right. So now let's try something a little different here. Let's go I to import 1 for ILDA, stay in the fonts directory. We're going to open Arial_1 again, replace the frame set. Okay, here it is. All right. We're going to go into J, which enables us to manipulate the entire frame set in one way or another. And option O is to randomize the order of the frame set. So we hit O, and now you can see there's absolutely no correlation to the order in which these characters exist in the ASCII character set. They're all randomized. All right, so let's save this randomized. Escape out of here. O to output. 1 for ILDA. 1 to stay in the fonts directory. 3 to save all of the frames in the frame set. And we'll call it Arial2. And yes, okay. So now Arial2 exists, and it's this randomized thing. So back into here, if we, let's change this to cyan. Let's just do this. Let's copy this whole thing. So here, this was yellow, right? And it uses the font named Arial1. And down here, this is a copy of it. We'll use the font frame name Arial2, and we'll make this one cyan. All right. So now, save it, and we're going to render this in 4 for text, Win10. And replace the frame set. All right. There's the first one that's in the correct order, and there's the second one. And you see it's randomized because LaserBoy doesn't have any way to know. It opens up the font frame set. It says, all right, we got 94 frames here. That's fine, but they're not named hexadecimal values for each frame. So we're going to assume that it's in the correct ASCII order from the bang to the tilde, and it's not. So you get this random nonsense. Okay, so now I'll show you something else that's kind of interesting. If we I to import 1 for ILDA, stay in the fonts frame set, open Arial 1, which, as you recall, this is in the correct order. All right, it starts with a bang and ends with a tilde, and they're all in the correct order. Okay, now if we, from here, we know that we have a UTF-8 file that has the ASCII character set in the correct order, we can open that to name this frame set. So if I say I to import, see, we've got this new option, UTF-8. We're going to open a UTF-8 file called Win10, which is, remember, that's how we made this thing in the first place. We know that it has the proper index in it, and we hit enter. And see, now it has, in fact, named all the files, or excuse me, all the frames, what they should be. See, there's 21 is the first one, and 7E is the last one. So now these have their correct hexadecimal frame names, okay? And again, we're going to go into J, and we're going to choose option O, and we're going to randomize this thing. All right, so now it's randomized, but the names are still associated with the correct glyph, right? So if we find somewhere, all right, there's the bang right there, and it is in fact 21, just like it was before, except now the order of the entire frame set is random. Okay, so now we're going to go out, 1, stay in the fonts directory, 3 to save all of the frames, and we're going to call this Arial 2, which is going to write over the one we already had, and say yes. Escape. Now, remember, this is randomized, but it's properly named, okay? So now when we open this thing that uses Arial 2, in 4, Win 10, place the frame set, escape, 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 escape. There's the one. This was Arial 1, which is in the correct order without hexadecimal names for the individual frames. And this is Arial 2, which was randomized, but it does have the proper names, hexadecimal names for each frame. So LaserBoy looks at this frame set when it comes in as a font frame set. It goes, oh, this does have hexadecimal values for the frame names. And so it uses the hexadecimal value of the frame name to find the character, as opposed to its location in the frame set. So this was kind of the first thing that I had to figure out, the departure from just the standard ASCII to be able to manage and render frame or glyphs that are outside of the standard ASCII character set. So this, if you were to use this frame set as a font frame set in an earlier version of LaserBoy, you would get that random business, because earlier versions of LaserBoy don't know how to look for the name of each frame to determine what the actual character is. So that's a major difference right there.